Okay, in the last video we looked at the properties of polynomials and how to graph them by looking at their end behavior and the behavior around the zeros. Now we're just going to do a quick video here where we graph a couple of them using those properties. So first off, and when I do these, I'm always going to write them in factored form just because it'll save us some time as far as finding my zeros. I don't want to make this video overly long by trying to solve those out. So for this one, first off, find the degree. Count the powers of x. There's 2, there's 1, there's 2. So this is degree 5, which means it'll look like a cubic. Go from down to up, or up to down. The leading coefficient is negative, which means it's a cubic flipped, which means cubics normally go from bottom to top. This one will go top to bottom. Now we have our end behavior. Now just find the zeros. Let's see. If there's an x out in front like this, that means you have a 0 at 0. You all know that from solving quadratics out. So we have a 0 at 0. X minus 2 gives me a 0 at 2. X plus 4 gives me a 0 at negative 4. Now just connect the dots. We start up here. We come down to my first 0. At that 0, to find the behavior around the 0, look at the degree. X plus 4, the factor associated with that, is even degree. If it's even degree, bounce off the axis, or your sign stays the same. So I go up. But if I go up, I have to come down. At 0, that's this factor, x squared. That's even degree. Again, since the degree is even, I bounce off the axis. So I go down, I come up, and I come down again. At 2, that's x minus 2. That's odd degree. Since it's odd degree, you cut through the axis. So I go down, and eventually I meet that. I guess I'll just make my arrow closer. And there we go. There's a rough sketch of my graph. It is as easy as that. Find the degree to find the end behavior, plug in the zeros, and then find the behavior around the zeros by connecting the dots. One more, briefly. Let's say we have f of x equals x times x plus 2 times x minus 3 times x plus 4 squared times x minus 5 squared. There we go. So first off, find my degree. Count the powers. 1 plus 1 is 2 plus 1 is 3 plus 2 is 5 plus 2 is 7. My degree equals 7, so it's odd degree. Leading coefficient's positive. So it's a regular odd degree. It's like a regular cubic. So draw an arrow going down, an arrow coming up. Now plot the zeros. X out in front gives me a 0 at 0. X plus 2 gives me a 0 at negative 2. X minus 3 gives me a 0 at 3. X plus 4 gives me a 0 at negative 4. X minus 5 gives me a 0 at 5. Now I have all my zeros. Connect the dots. We start down here, we come up, we have to hit negative 4. Degree of negative 4, x plus 4 squared is even, so bounce off. I go down, I have to come up again. At negative 2, that's x plus 2 odd degree. Odd degree cuts through. So I cut through, but if I go up, I come down. That's x. X is odd degree, so I cut through. I cut through, I come back up. At 3, that's x minus 3 odd degree, so I cut through again, but if I go up, I come down. At 5, I get x minus 5 squared. That's even degree, so I bounce off. So I hit 5 and go back up. And hey, that works fine, because it connects me with the arrow I'm supposed to get. The last little thing I'll say about this, don't just use your calculator and copy the graph in your calculator. Sketch these out by hand. And when you're doing it, don't say get to the end and say, oh, I'm supposed to cut through down here, but the arrowhead is up there, so I'm just going to curve around and do that. Don't do that. These things have to work out. There's only one way to draw them, and they have to work out correctly. Which means if you get to the end here, and the behavior around the zeros has cut through the axis, but you're supposed to bounce off, then somewhere in here you made a mistake. Go back and check everything and find your mistake again. Don't just make it work. It has to work a certain way if you do the properties correctly. And again, lastly, don't just use your calculator. That's no fun. Try to do these by hand.